Hello everyone, welcome to Math with Cam. In today's video, we're going to be going over geometric sequences. So we'll go over the definition of what a geometric sequence is, and then we'll talk about common ratios as well. And then we'll go over a couple problems just to make sure we understand and we can put it into practice. Before we start this video, do me a favor and give it a thumbs up and subscribe to the channel. It greatly helps me out in terms of getting my videos out to everybody. So once you do that, we'll get started. Now starting with the geometric sequence, we can see that we have this example on the right where we have a 1, then a 2, then a 4, and then an 8. And then we have these dots over here, and that just means we're going to keep going on with that pattern forever. Now, the important thing to know is when we reference these numbers here, we're going to be calling them terms. And specifically, we can say this is going to be our first term. This is our second term. Our 4 will be the third term. And you guessed it, 8 is going to be our fourth term. So within sequences, these numbers are considered terms. Maybe you're looking at the sequence and you can see a pattern going on. And that's good because this is actually what a geometric sequence is. This is a really good example of that. We are going to define a geometric sequence as a sequence of terms that is created by multiplying by a constant factor. Now, this common factor that we're mentioning at the end of this definition, we are going to be referring to this as our common ratio. A common ratio in a geometric sequence is a constant factor between each term. It's the number that we are multiplying by. We've covered geometric sequence and common ratio. Let's try a couple problems just so we can see this all in practice. So looking at this first example, it asks us to determine the fifth term in the geometric sequence 2, 10, 50, and so on. We can see here that we have our first term is going to be the 2. Our second term is going to be the 10. And then lastly, our third term is going to be the 50. We need to figure out what the fifth term is. And in order to do that, we need to find out what the common ratio is within this geometric sequence. That's going to be the first thing we need to do. Now, I'm not going to lie to you. Sometimes you could just look at a sequence and say, oh, that's the common ratio. And then we can go on to the problem. But if you can't do that yet, that's okay. One way that will work every single time in order to find the common ratio is that we can always divide by the successive term. What do I mean by successive term? All we're saying is you take a term in the geometric sequence and divide it by the previous term. So because we can do it this way, we can't use the first term. You would have to start off with the second term. So let's use this into practice then. If we are trying to find our ratio, let's take our second term, in this case it is 10, and we will divide it by 2. Now, if you simplify this, 10 divided by 2, you will get 5. This 5 means that if we were to take 2 and multiply it by 5, we should get 10. And we do in this case. A way to also just to confirm that this is true for the entire geometric sequence is, let's use another example. So let's take 50 in this case and divide this by the successive term, which is 10. And 50 divided by 10, yep, it's 5. Let me write that a little better. Great. So from here, we can see that our ratio is indeed 5. Awesome. Now that we have our ratio, we can now actually find the fifth term in this geometric sequence. That was the whole point of this problem. Let's rewrite the sequence up above, and then we can actually see how to find the fifth term. So we have 2, and then 5, and then 10, sorry. And then we have 50. So just to confirm with our common ratio, okay, if I go from 2 to 10, I do have to multiply by 5, and that does work. 2 times 5 is 10. And now if I multiply 10 by 5, oh, I get 50. So this is working. In order to find the fifth term, I'm just going to keep going. So I'm going to multiply by 5 with the 50, and I get 250. Cool. But this is our fourth term. The question was asking specifically, what is the fifth term in this geometric sequence? All we have to do is just go one more time. We'll take this 250, multiply by 5, and we will get 1,250. In case if anyone was wondering how I did that in my head, I kind of just ignored the 0 for a second and I said, okay, what's 25 times 5? Well, 25 is like quarters and 5 quarters is $1.25. So that's 125, 125. And then, I took away that 0, I brought it back. I know that's kind of random, but if you're interested in how to do this mental math and kind of the tricks that I use in future videos and in previous videos, let me know in the comments below. I'd love to make videos like that for you. But anyway, going back to our problem, we can see now that, we had our first term, second term, third term, fourth term, and now we have the fifth term right here, 1,250. So if I make a little bit more room over here, the fifth term is 1,250. And now let me box my answer. And there you go. That is how you would find the fifth term in a geometric sequence. And you can kind of repeat this pattern to find any term in a geometric sequence. Let's do one more just to make sure we understand. This problem now says determine the fifth term in the geometric sequence, which is 12, 6, 3, and then so forth. So again, we see 12 is our first term, 6 is our second, 3 is our third term. Now something's interesting with this sequence, and it's specifically that the values are going down. But in geometric sequences, we keep multiplying by a common ratio. Why is the value going down in this case? Well, this is actually a unique situation. Instead of having a number like 2 or 5 or 20, whatever it may be, in this case, we're going to be multiplying by a factor that is less than 1, specifically between 0 and 1, and it's probably going to come out as a fraction, so heads up there. Now again, maybe you can just look at this sequence and you can say, I know what the common ratio is. That's awesome. I would keep that up, but I'm going to use the method that I showed before just to confirm that this is what it is. So with our ratio, we're going to take a term, not the first term, so we'll start off with the second term, and we'll divide it by the successive term, which in this case, if we started with 6, we'll take the term right before it, which was 12. From here, it doesn't go in evenly, but I could reduce this as 1 over 2, so a half. And that would be my ratio, which makes sense because if I take half of 12, I would get 6. Let's confirm with the other example just to make sure. So we'll take 3 and then divide by 6, and 3 divided by 6, that doesn't work evenly, but I could reduce that as 1/2 again. Now I know if you're thinking, 0.5, why don't we just say that? Sometimes it's a little harder to use that when we are trying to find our terms in the geometric sequence, so I'm just going to stick with fractions in this case. Now that we have our ratio, and again, we are confirming that it is 1/2 because we got that both times, let's now use that to find our fifth term. We will rewrite our sequence, 12, then 6, and then 3. And just to confirm, let's use the common ratio to make sure. 12 times 1/2, so 12 divided by 2, that is 6. 6 times 1/2, you can think about that as taking half of 6, that is 3. And now, what's 3 times 1/2? It doesn't go in evenly, and we might have some remainders and all that stuff. I'm just going to leave it as a fraction. So I'm going to say this is actually 3 over 2. So I'm just going to leave it as a fraction. And if I were to go one more time, because again, this is our fourth term, we want the fifth term in this case, multiply by 1/2. And how do I multiply fractions with fractions? Just a side note over here. 3 over 2 times 1/2. All you do when you multiply fractions, you're just going to multiply across. Not diagonal, that's cross multiplying, totally different thing. You're just going to be multiplying the numerators together and then the denominators together. So in this case, 3 times 1 is 3, and 2 times 2 is 4. So 3 over 2 times 1/2 is 3/4. So our answer is 3/4. So this is our fifth term. And just to confirm, the fifth term is 3/4. And just like before, let's box our answer. Perfect. And there we go. That's it. So this is the idea of geometric sequences and how you can find specific terms using its common ratio. All right then, I hope you found this video helpful. And if you did, I would really appreciate it. Just like the video and subscribe to the channel. It greatly helps the channel to reach a bigger audience, and I would also really appreciate it. So thanks again for watching, and I will see you in the next video.